Okay, so I will start my lecture here. First of all, welcome. I'm amazed. So many people who want to have a look at software-defined radio. Great. Don't expect too much. I'm not a programmer. I'm just a practical guy. I'm playing with this kind of stuff for years now. And in fact, I started playing with radio and RF maybe 30 years ago as a child. Now I'm age of 43 and still a bit of a child and, well, playing with RF. I came to the software-defined radio 1 year ago, so it's relative new to me, but the learning curve is relatively steep. It's quite amazing what is possible with all this stuff. Okay, so first of all, I will start with a few words about me. I have studied communications technology. I have worked for a radio company, a smaller firm. We were so between 6 and 8 people, and I had a lot to do with authorities, also with special installations in, for example, cars for observations, stuff like that. So I have seen, let's say, both sides of the game. The interesting thing is I never had to sign some NDA or whatever, so I can talk about it relative free, but also I did, of course, not see that much. It was only, well, you get a feeling how these guys work, what they are doing, and yeah, it widened my view a little bit to the dangers and to the risks, what all this communication stuff brings. We also have now with the PRISM stuff and all at Snowden and so on, it gained some actuality at the moment we did not expect. But okay, it's in this case not mainly radio frequency he was involved in, so it's a little bit different, but at least it's a similar field. So when I started with SDR, just a few practical things. The smallest SDR is this one. It's a quite cheap receiver. You can buy something like that for 20 or 30 euros. It is in fact a receiver for digital television and DAB plus radio. You can get it at electronic discounter, other discounters at the internet, wherever, quite cheap. And that's also the reason why I started Windows. There's some kind of Windows software available. This is freeware. It is open source. You can, almost open source, I think. You can download it, install it, and it is a matter of 5 or 10 minutes, and you can receive with it. It's a wideband receiver, 50 to 2200 megahertz. So I think you can receive almost everything that is analog on the air here in Germany or in Europe. Also, you can receive some digital stuff. And this is just to get a first impression. What's happening here? I don't need this now. And my first attempt here was to find this wireless microphone I'm talking with, but I still do not have the frequency, but maybe we will find it, or they have it here on the display. Yeah, okay, we have LTE 4G here on the frequency band. Different stuff. Okay, so first of all, what is a software-defined radio? Maybe many here already know, maybe some have no idea. I will try to keep it simple, the technical stuff. Usually a radio receiver is an array of amplifiers, mixers, oscillators, whatever. Here it's almost all software. You have a converter for the receiver, analog to digital, and mainly that's it. There are two kinds of software-defined radios. It depends how much money you want to spend for the converter and what frequency range you want to receive. There are very high frequencies in the gigahertz range that usually do not fit directly into a converter, so there's a mixer in front of it, but basically that's all. And the opposite way, when you want to transmit, it's almost the same. You have a converter digital to analog, and maybe you directly connect the antenna to this output and even have some milliwatts of power on the air. Otherwise, you have amplifiers, filters, or you mix it up to a higher frequency, but that's it. All the modulation stuff, how the information is transmitted or received, it is all done in software. If there comes up some kind of new type of modulation, new coding scheme, whatever, it's just a matter of a software update. As far as the bandwidth of your setup and the computing power is enough, it's just software. So of course also it's very simple to implement the analog modulations, AM, FM, and the from that derived versions, SSB, whatever. It's all possible in software. It all can be received and decoded with this quite simple program. Here we have some signal. I cannot find this microphone. But okay, I'm searching too fast. Would need some more time. But doesn't matter, it's not important. Of course, also you can have a look at the GSM spectrum just to see there are different GSM carriers here now with a bandwidth of about 200 kilohertz. And so we come to another practical application. For this, I will reboot this computer to Linux. But in fact, I'm not very good in the Linux stuff. I started maybe 1 year ago using it just for this purpose. Otherwise, I could all do my work with Windows. I know maybe some people here do not want to hear this, but it doesn't matter. So hopefully the external display is supported, but I think I will find some help here if it will not work. So while it is booting, some other words about this stuff. When talking about software-defined radio, the normal person has no idea of it and is not interested in and says, well, just another technology. But of course, there's also some influence on our society from this stuff. We have visible and not so visible effects. One visible effect is this kind of cheap receiver sticks. It was no problem at all to use just another software and receive digital audio broadcast with it. It was sold for television, but it was no problem to use it for another purpose. Also, it was quite simple to use it for this funny software we have seen right here. Also, we have not so obvious effects. One thing that is a benefit, I think, have a look at the 3G and 4G mobile networks. The latest generation of base station is all software-defined radio. They have a given bandwidth of maybe 20 or 40 megahertz maximum. And the modulation scheme is just a piece of software that is loaded onto the system. It has the advantage when new technologies come out, like we had it with HSPA plus and dual channel and whatever. It's just a matter of upgrading the software. No one has to drive out to all these thousands of stations and replace modules and do alignments or whatever. They basically could do it from their operation and maintenance center, install some new software, and the network gets faster and better. This is one thing. Of course, the same applies to other digital systems like digital television broadcast, digital audio broadcast, stuff like that. These all are more and more SDR solutions. And I think this is some kind, at the moment, the end of the development. At least I cannot imagine what could be done better. They will get faster, more computing power, better frequency range, more power efficient, but I think now we have reached a point that will be the state of the art for some years or decades or whatever, but who knows what the future will bring. Also, it has an interesting effect for so-called third world countries with bad infrastructure. It has become quite simple and easy to set up communication networks in those countries. It's a matter of a few $1,000s, and the main problem is to find a place for the installation where it will not be stolen and where it will not vandalized or whatever. But when looking at some African countries, for example, they get the most gain, I think, from mobile communication during the last years. They can start doing their money transfers via short message or whatever. They can talk to each other. They can check out which market brings the best prices for the grocery this day and all stuff like that. And this has been also pushed forward by these systems. It is quite simple to set up a GSM base station. Maybe some of you already have found the network. I have set it up in front of this room half an hour ago, and I think 3 or 4 mobiles already had logged in. So do we see here something? Yes, we have a picture. That's great. Anyway, there's not very much to see. I just start a script here, one moment. So within 5 or 10 seconds, we should have a carrier on the air on the GSM 1800 megahertz band. Oh, by the way, all what I'm doing here is fully legal. I have obtained a license. Just move it. Oh, not so perfect, but yeah, this one. So better? Okay, great. So at least you cannot see very much here. There's a kind of simple command interface, but in fact you could now log onto this network. You can do a network search and hopefully you find it. I also will turn on one of my phones here. Yeah, Android, it takes a time to boot. I got this license from our German telecom authority, the Bundesnetzagentur. It was quite simple to do it. It was amazing. I wrote them an email and I got back 2 PDFs. I had to fill in some facts. I did it and I had to pay, I think, 130 euro or something like that. Yeah, and I got a license. Yeah, the first one got lost on snail mail, so I got it emailed. I was not quite satisfied. I had asked for a nationwide license, but they only wanted to allow me to use it at home at a given location. But even this was not so difficult to solve. I just reduced my transmit power to a very low level, and so they found out, okay, then you will get a license for the whole country, and well, that was all. I have to renew it every few months, and for sure they will charge me with some euros for this every time, but okay, at the moment it is still fun, and so I will go on with this license. So I will just have a look at the list if someone already, oh yeah, we have many new subscribers here. Yeah, that's interesting. It's maybe 6 or 7 more. Okay, the first ones try to get a phone number. The system is not perfect. It gives, when you try to register with a short message, it gives some error back, and I also have discussed this on the openbts mailing list, but there was not a real solution, so I thought, well, let's live with it. It's not a commercial system. It's not a problem. One thing, the authority did not allow that I connect this to some phone networks or whatever. But okay, this was never my intention. I do not want to set up a commercial phone system. I just want to play around. Yeah, and I see there's again some activity. There are 2 ways to get a phone number. You can send a short message like it is in this greeting message, or also you could just call a phone number and go through a voice system and choose your own phone number. Most time it works, not always. But I see some people are playing on their phones. Depending how your firmware is set up, maybe it will identify itself as a satellite network. Of course, this is not true. It's just on this table, but well, I found this quite funny. And the other name that could be shown is just the name of this conference here. Yeah, okay, I know this voice, yeah. So it works. So it is the first time that this system really gets some load. Of course, how can I handle more than 2 or 3 or 4 phones myself? So this is also quite interesting if it will break or if it is so far okay. Yeah, settings, I will have a look how it is done. I have no idea how this works. Configure profile. Appearance. No. If anyone wants to have a look how this is done, no problem. Feel free. Appearance. Ah, okay, text size. Yeah, here we are. Apply, okay. Is it possible to see something here? Yeah. So I just will increase the window a little bit. Yeah, provisioner. The provisioner is this guy that talks to you when you call it. I want to verify. Yeah, I have never seen so much in this window, so many phones. Yeah, the list is getting longer and longer. But also you can see the danger that lies in such a system. What we have here is in fact the simplest version of an IMSI catcher. So this is the system that authorities use to spy on phones of suspects or whoever. And usually those devices cost some 50 or 80,000 euros, and Rode und Schwarz sells not to everybody. You must be maybe a German 3-letter agency or maybe also some Saudi Arabian agency or whatever. They sell it almost to everyone, just not to the people. And now this has become available to the masses. So here I do this with a license that is a relatively wide license. It was amazing. They did not force me to use some special identity or whatever. It was only a few words. I should have it here. Maybe I can show it later. But also, you can see this one, of course, can be shrinked. I have ordered a system. It's not yet arrived here. It was a Kickstarter campaign, and they just have been produced, and now they are delivered. And it should have the size of a 2.5-inch disk drive, an external one. And if you put it in some kind of a housing like such a disk drive, you do not, the people won't notice you. You sit somewhere in the train or in an office or in a restaurant or whatever, you have your notebook, you have some small black box, you set it up, and then you can collect all the data from the phones around you, and this definitely is a danger. And I know from my contacts that also some authorities have started to check these little boxes and find they are much cheaper. I do not have to go through some process of ordering it because it's so cheap. So maybe even they can put some private money together and buy such a thing to have an easier job. Of course, this would be highly illegal, but usually no one cares. Yeah.
What information are they interested in?
First of all, they are interested in the identity of a phone. So let's let's think about the legal version that is accepted. So maybe they have found there are some drug dealers and they meet in some place all the time and no one has an idea what their phones' identities are. So they just try to get into the house and walk the stairs up and down. They have some kind of rucksack like this one, not very suspicious. They have some technology inside it. And then they collect all the numbers they get. Of course, they get them all, also from people that are not affected, that have nothing to do with the drug deal. So this is the first danger I see. They collect data of people that have done nothing wrong, and usually they never will hear from this. Then they start sorting out the data with the mobile phone providers. And now they have identities, phone numbers, usually no names because they are anyway fake names, but at least they know what phones they should tap on the provider side. But also, they could go further with those little boxes. They could route all phone calls through the box and listen live into the conversations without any warrant. No judge has ever had a look at it if this is legal. So it is possible, and I'm sure it is done in Germany. I have some cases. Okay, one was a military case, quite interesting. In the middle of nowhere, where usually no GSM phones work, there was some military exercise of a higher level. And there was one green car with some antennas on it, and no one, even the leaders of the exercise, were allowed to have a look what's happening there, what they are doing. And the funny thing was, suddenly, in the middle of nowhere, all GSM phones had perfect reception. And, well, you cannot find out what they are doing, if they are just registering who is calling whom, if they really tap the whole conversations, who knows? Another thing, a big German company, they have some conference rooms that are shielded to the outside. So no reception, no GSM, nothing, but your phone works. Okay, it's only GSM, no 3G, no 4G. And when you try to ask if there's some kind of indoor installation, no one knows, no one has an idea. Yeah, who knows? Maybe there's some special agreement. Of course, they fear terrorism, whatever the word that goes around all the time. And maybe they have some agreement and tap all phones, even all phone conversations. Who knows? It's in Germany. It's in Berlin. It's a large building of a big German company, and it's their, I think, their main building, main office or whatever, and they have this shielded conference room. I have seen this conference room and I was wondering, no reception, so I had a closer look at the windows. It was like here, large windows, everything was visible, but there were thin wires in the glass embedded, and it really worked, so there was no communication possible just over this in-house system. The in-house system told it was German Telecom, but yeah, who knows? So I'm just having a look. It's still alive. So at least it can make the load. The system does not answer. This is not good. Okay. But it seems to work. It's still, or no service. Are you still logged in? No? Okay. So I will just stop it and give it a new try. I have not managed yet to crash it with my 3 or 4 phones, but okay, maybe this was simply too much. Yeah, now it should be live again. new subscriber. So you see this identity here even tells the country. You have, the most of them are 262, this is Germany. I have 460, could be somewhere in Asia, but I'm not sure. 208, 206 could be more Eastern Europe, maybe Czech, Poland, whatever. 293, I have no idea. Yeah, but at least it seems to work again. Yeah, 71, next one. So the list is filling. And this number would be enough to identify the phone from the provider to find out who one is. Of course, only if you have the access to the provider, maybe official or unofficial or with a backdoor. So I do not trust the providers that much that they have full control over their customer data all the time. There are for sure some interfaces for three-letter agencies, whatever, where even the number of requests maybe is not recorded. I can imagine this at least. So of course this software-defined radio also makes much fun for stuff, amateur radio. You can decode digital modes, you can transmit digital modes. It also is a great transmitter and receiver for analog modes. It is equipped at the moment with a module for 50 up to 2200 megahertz. This covers the most interesting VHF, UHF bands here in Europe. Unfortunately, not Wi-Fi. There are different modules available up to 5 or 6 gigahertz. So this box here can hold up to 2 transmitters and 2 receivers. I have equipped it this way. I have one from DC up to 30 megahertz, transmitting and receiving, and the other one I have already mentioned. This box is about maybe 1200 euro, around this, how it is here. It can be a bit cheaper, you can spend much more money, but you see a computer is usually available, so with very low money, some really very professional communication equipment can be set up. This can be amplified and filtered to cover a bigger range. There's this Burning Man festival in the United States every year. They, for those who have not heard about it, they set up a whole city in the middle of nowhere. I think it's in the desert of Nevada or wherever, with 40, 50, 60,000 visitors. And there's no communications infrastructure out there, no mobile phone network, or at least almost no reception. And so they set up their own network, and it's the test case of this open source project every year, what the improvements brought, how stable the system is, will it hold the load, and so on and so on. And I can imagine it's every time quite interesting to view through the logs. They do some research, what are the people doing, are they sending short message, are they doing phone calls, whatever. And yeah, of course, it's not only for playing with GSM and stuff like that, so I will just shut it down. Yeah, this setting is okay. Of course, you can do similar stuff like with those little things, only much more better and much more sophisticated. I have prepared nothing, but I just wanted to start this environment. It's the GNU radio. It's a complete, let's say, development suite for open source, for radio stuff, SDR, and you can simply put some transmitter or whatever receiver, whole radio systems together with those blocks. They can be modified. So I'm just having a look. Yeah, I have a transmitter that just gives out an FM signal with 2 tones modulated on it, a quite simple thing. and it's quite easy. If you know a little bit about radio technology and how this stuff works, you just put this together, press go, and I think it should transmit even without having anything prepared. Yeah, now it's transmitting. Oh, okay, somewhere on a frequency where we should not. I have used this GSM frequency I have the license for, but of course now this was not a GSM transmission, but no one should care. But you can also put this somewhere in the 400 something megahertz range. I will just put it on the frequency of my repeater, because this one I can have very fast on my radio here. Just turn it on. This is also a software-defined radio. Come to it later. So at least we have a carrier. There's no modulation, so maybe there's still something wrong. But it is doing something. When I stop this, yeah, the oscillator is still radiating. Okay, not what it should do, but it does something. This here is also a software-defined radio. It looks like a quite old police handheld radio, and in fact it is. It's an US police radio, I think Los Angeles Police or whatever. It is able to do 3 modes. Digital, some kind of digital app code 25 mode. This is a common mode used especially in American public services, whatever. It can do some kind of digital FSK modulation with encryption that is quite old, 20 or 30 years old. And then it also can do simple FM modulation. It's just a matter of a flick of a switch what you want to do with this radio. And this technology is already, I think, 10 or 12 years old, or even older. So they started quite early. The original price for such a radio was about $6,000 or $7,000 US. Now you can buy them for maybe 100, 200 euros from eBay. I think they are now even out of service because newer models are available. Also, the new digital radios for the German authorities, like Tetra, should be software-defined radios. I'm not absolutely sure. I have not looked that deep into them, but at least it would make sense to do it this way. But I don't know exactly. Interesting is that normal mobile phones or USB modems for 3G, 4G still usually are not SDR radios. I think it has one reason: they are produced in really large masses, and then maybe it's still cheaper and maybe also more power efficient to design some special chipsets for this purpose. But we will see. I can imagine the newer ones also will go into the direction of software-defined radio, and this may come during the next years. So far, I have told a little bit about SDRs. Are there any special questions? Yeah. The internal clock? Yeah, that's a good question. So I think you also have worked with it, otherwise you wouldn't ask. Yeah, okay. The standard clock is a 64 megahertz oscillator, and it has maybe 10 or 20 parts per million or even worse. So at the high frequencies of GSM 900 or even 1800, this is not enough. It works fine in an isolated environment when no other GSM signals are around. But when a mobile phone starts searching the band for a GSM carrier, okay, sorry, I should repeat the question. The question was if I have some special setup for the internal clock of this unit, the master clock, that supplies all the logical chips inside the transmitter transceiver chips and so on. And the problem is, especially when you want to do GSM, you have to be within some hertz, 30 hertz, 50, 40, 50, 60 hertz of the frequency you want to be on. Otherwise, the phones will not find you. The problem is, when you have a normal mobile phone and go on search, it will hop onto the strongest signal. This is from a commercial carrier, usually outside. And the further search, to be a little bit faster, is narrowed down in the frequency offset that is allowed. And then when your own station has a too large offset, it simply will not be found. It's not a problem if you go into the cellar where no other reception, but in an environment like here, this is a problem. But I was lucky, I found some oscillator off eBay for maybe 5 or 6 euros that is temperature compensated, and it has the possibility to be trimmed, so it was not a problem. I let it run for 10 or 15 minutes to reach its temperature. I was able to trim it almost onto the hertz, and so it works. So this is not a problem anymore. So now we are already deeper into technical details. I have not expected this, but it's not a problem. Some other questions, yeah?
Given software like Free Radio and an SDR, could you also do something like build a jammer?
Yeah, it would be possible to build a jammer. Of course, this unit has a limited bandwidth. It will be with this computer and over USB connection, I think. Again, the question, yeah. The question was if it is possible to build a jammer with the radio. Yeah, it would be possible, but not a very efficient one because the output power is very low. And if you spread the output to a wider frequency, then of course it's even lower per channel, but it can be amplified. The main problem would be the bandwidth that is possible. With this computer, it's only a Core 2 Duo with 1.6 gigahertz, so it is relatively fast at the limit. Also, it's only a USB connection to this unit, but also other units are available with a bigger bandwidth, and when you can reach maybe 20, 30, or 40 megahertz, then at least it should be possible to, for example, jam the complete GSM 900 band. Also, of course, it would be possible to jam maybe the new digital police radio system. They are using about 4 or 5 megahertz, so it would be possible. But the whole energy is spread over a larger bandwidth, so you need very much power and very large amplifiers for being able to jam in a larger area. Also, there are some interesting things regarding jamming. When we have a look at those digital radios from the United States, they have encryption, and it can be switched usually from the user. And when encryption does not work, so the unencrypted communication is the fallback. And now some hackers in the United States, I think, found out there's some toy device. It's pink, it looks like for little girls, and in fact it has a complete little digital transmitter and receiver inside it with some Texas Instruments chip. I think it's available for $20 or $30 from Toys R Us or eBay or whatever. They wrote an own software on it to have a little spectrum analyzer. Okay, my wife would kill me if I walk around with some pink device and look at the spectrum, so at least it would have to be black or gray or whatever. And also, they found a way with this little thing with only a very small transmitting power to detect the stream of data that is flowing when the police officers are talking, and just pinch out this single bit that is for the encryption. So the encryption will not be recognized, will not work, and the people, it does not work, crap, let's switch to conventional unencrypted mode, and now you can listen to it. And this is a very nice attack, I think, with relative low power. You just kill 1 bit or 2 or 3 bits in the telegrams, so you need only short peaks of power, and you can really change their system from encrypted to open. It's all available on the internet, so I'm not telling any secrets here. You can Google for this. Should be possible to find it within a few minutes. At least it was an interesting approach. I think this will not be so easy in Germany with the Tetra system, but okay, who knows? Maybe there are other problems in the implementation that no one has found yet. But I also must admit I did not have a deeper look in the Tetra system. I found this American system more interesting because it can be used for ham radio. It's a relatively efficient and simple system, so I have more focused on this. Any other questions about it? So we just have still some time left. Everybody is happy, so I must think a little bit if I have some ideas what I still could tell you.
Can you explain how difficult it is to actually build an IMSI capture from the openbts?
Yeah, it depends on the features you would like to have. So just the original functionality, the IMSI catcher itself, what does nothing but catch the IMSI, well, I started working with Linux for using this radio. It took me a few days to find out how to download and how to compile it and stuff like that. But basically it was more the basic stuff. I ran into trouble how to use some Git repository and how to compile this stuff because I have never done it before. But when you know this, when you're a pro, so when you go just after the book on the openbts side, the main time it takes is to compile the stuff. Yeah, definitely. I have written a really simple and dumb script that just repeats all the steps from the website written one after another, because with my first playing around I messed it up too often and had to redo the whole thing. And well, I just let it run, and it takes, yeah, it depends on the dependencies. If they are already installed, it takes maybe 20 or 30 minutes to run and compile. Then you can configure the network identity, the frequency, you give it a go, and that's it.
And I just set the identity to say T-Mobile or...
Yeah. The question was if the identity can be set to whatever you want. Yeah, this is possible. You can configure the MCC and the MNC to whatever you want. You can give the network a short name that is transmitted over the air. So here it's the name of this convention here. But yeah, usually test networks are just 00101, but you can, of course, you could use T-Mobile. In fact, our German authority did not make any demands what I have to use. I will not use T-Mobile or whatever, because even if it's not illegal, they could sue me on the civil way. So I do not want to do anything strange here. So I just took one that is not available here. I took this Turaya satellite network. I found it interesting. Why not a satellite network? Also, it isn't. Yeah, one over here. Yeah, the question was if bidirectional authentication is possible. The German networks on 2G, on GSM, do not use this as far as I know. And this system, I think it could be possible. There was some talk in the mailing lists about authentication issues, if it's possible or not, but I must admit it was not so interesting for me, so I didn't follow this deeper. but at least the mailing lists are open to everyone, so it's just a normal openbts mailing list, and you just could enter it and ask, and I'm sure Curtis Heimel or one of the other guys will be able to answer it. Yep. The question was only GSM or also 3G UMTS. It's only GSM possible at the moment. I think there was some approach to hop onto UMTS 3G, but it's much more difficult from the hardware demands also and all the software stuff. And on 3G, you would have this authentication into both directions. So when a GSM IMSI catcher is used, usually they jam the 3G bands that all the phones fall back to 2G GSM, and then everything is possible. At the moment, I see some movement into direction of LTE of 4G, and I think there's already an implementation available to transmit a predefined telegram, kind of predefined sample that at least can be seen by the mobile radios, by the phones, but nothing more. There's also a commercial solution available that can be used with this kind of software-defined radios. I have asked them, it's in France, and they want something $4,000 or $5,000 for it, so this is not interesting at the moment for just hobbyists for playing around.
So you say the visual IMSI catchers jam the 3G and don't fall back? Should I tell my phone not to use GSM?
Yeah, that's right. The question was if it's when an IMSI catcher is used, that they are really forcing this fallback to 2G, and to circumvent this, to force the phone being in 3G mode. Of course, this is possible. Then you will lose complete network connection in this case, and at least you see there's something wrong. But of course, when the ones that spy at you work together with our authorities and the network operators, I'm sure they will get the key to fake this authentication into both directions. I'm sure. But a kind of rogue IMSI catcher, when they just take it, maybe a thing like that, in this case, usually it still should be safe when you stay on 3G, definitely. GSM is much simpler to program. The computing power is not so high that is needed for it. So when this station is running, this really slow PC is maybe at 10 or 12 or 15% load, so it's almost nothing. No more questions? Yeah. Yeah, yeah. He wanted to add something. He Googled for this little pink toy that was able to interrupt police encryption. Of course, it is right. This system also is used for military purpose and police, rescue, even some companies use it to secure their communication. But of course, the most interesting, the highest interest is made when you talk about police radio, but of course all the other systems also are affected. And in fact, this standard comes from some kind of police organization, but it is widely used in the United States for very different purpose. Also, maybe the highway department that do the repairs, or power energy companies, they all use the systems. Not all encrypted, because encryption is expensive. You have to pay a few $100 extra for every encrypted radio. But some even do this and use it that way, yes. Yeah.
You know any UMTS catcher that uses the provider authentication
The question was if I knew any 3G capable IMSI catchers that also can authenticate to the handheld. I have no idea. I think it is possible. I think it exists, but because it's all software. It's only a software-defined radio, and it does what the guys program into the software. So I think it is possible. But if there's an official solution or if there's some unofficial solution, I really don't know. It's difficult to find out. I know some guys that could know it, but I do not want to bring them too much into trouble asking them for stuff like that. Yeah.
I think a year or two ago, there was some talk about this on the SIGINT Congress, where they talked about the Oslo date. Do you know about that?
Yeah, the question was regarding CCC Congress, Osmocom, and so on. I know this project, but I'm not yet working with it. I think I will need some Osmocom stuff to bring GPRS to work with this unit. And well, I did not find yet the time to go deeper into it. I tried it on the quick and fast way, and it did not work, and so I stopped it because it took too much time. But I have been in contact with one or two of those guys from Osmocom sometimes, but not so deep. Yeah, okay. So I think we're through it. Well, it was 1 hour.